Hello everyone and welcome back to the 3D printer vlog here. This is your host Michael, and today I'm going to be showing you a bit of an update after our long hiatus here. Now the main changes I've been working on here recently are these bushings. I guess you call them bushings. Yeah, that sounds about right. Or spacers, washers, whatever you want to call them. I'm starting to replace them with metal. The cool thing about that is, if you notice here, this is super smooth. I already replaced all 4 of these with it. There is no, of course these aren't fully attached. They're just kind of loosely on there. So there is no play in this here. It just goes back and forth, nice and smoothly. Little to no resistance here. All the bearings move freely. So I'm going to show you all what was going on. Here we have the old design here. Basically, what happened is these are the plastic bushings here. There is a little bushing in the middle in the wheel between these 2 bearings. Now the problem was these bushings, along with this little washer in here that was plastic as well, they are way too wide. So this is the center of the bearing, the free spinning, or the part that's independent of the outer part that allows it to spin freely. Now, of course, when you clamp the screw and the nut down, these outer bushings and this inner bushing would compress inwards. What they would do is they kind of like bunch up and expand. And of course they would seize up the bearings here to where the fact that if I had them too tight, they would not move as freely, or they'd be really restricted in movement. That's a big problem there. You're gonna get a lot of resistance. The motors are gonna have to work harder. They're gonna heat up, which they're already in a pretty heated, environment. So definitely not good for longevity. This is the new system here. Basically, we have a smaller metal washer in the middle, something that with pressure cannot expand, and then another 2 steel washers on the outside. And these are metal bushings here, or metal spacers. However, they're smaller. They're 1 millimeter smaller to account for these washers here, and they're a little wider. That's why I have these outer washers. So there's no issue for the bearings to go, or when the screw and the nut get completely tightened up. So we can have really tight, there's no free wobbling movement with this setup here, and just it's pretty smooth, so definitely works pretty well here. That's that at least. So now we can go ahead and focus on some other things like the end stops. A lot of people have been telling me, I haven't been explaining this to them. I really haven't. I've been pretty crap at explaining all of this here. So I'm gonna go ahead and go in depth here. The end stops start out, sorry for the terrible focus here, there we go. So as you can see here, I kind of drew it. There's supposed to be a bigger screw head on this, and it's kind of hard to see, but yeah, there's a switch right there, part of this contact. Basically this is a end stop, otherwise known as a limit switch, and what that does is when this axis is trying to find out where the home is when you first start a 3D print, it will do this, so all the axes will go to the home. The Z will raise up all the way to the highest point it can go, which is adjusted by this screw and pushed by this switch up here. What will happen is all those screws, or all those end stops, will be pressed, and the printer will wait for a signal until it is pressed. It just to make sure that everything is homed in properly, and so the printer knows where everything is. Just kind of like just a homing feature basically. Oh, and another thing I have with that jig I printed out in a previous video, I did get the screws ground down properly. It worked pretty well, although I would recommend if you're using it with like a belt sanding machine that you print out multiple of those jigs, because what will happen is when I was sanding it here, the screws would get really hot for one, and 2, they would degrade down after about like 4 or 5 screws. So it was kind of getting a bit difficult here. See if I can find this. So as you can see, get some better light on it. Yeah, kind of beat up. It still worked pretty well. It did, it got the job done, but yeah, it definitely would have helped if I had like 2 or 3 just to alternate between. I might put that on the store along with, like, of course, just to give the option for any type of screw here, because it is a pretty useful little tool, and of course I can sell in packs. Pretty satisfied with that result here, pretty nice. There's a better zoomed in result. So before, it looked like, looked like that minus the washer, and yeah, now it's completely sanded down head. Comes out pretty clean. You know, of course, it looks a little rough, but not too bad. Now, yeah, what I had to do is I had to do one more of those end stops, get that taken care of here. And I noticed that the Z-rods still need a spacer, so I'm probably going to design that. But okay, so yeah, taking a little break from just fixing the 3D printer. I already got all the metal bushings in. You need to do some few alignments and all the axes will be fine. Another thing I've noticed is the frame is a little bit wobbly. I'm going to have to print out more of these like corner brackets and attach them to all the corners I possibly can. Just nets more stability. And as for the other printer, it was having some issues staying level. First off, the springs that came with it are too tall. So, and of course, what you want to do is you want to go for as thick of a spring as possible and one that's short. There we go. As you can tell, the one on the right's a little bit thicker and not about half as tall. You don't need a whole lot of up and down adjustment here, just enough to like get it level within like a point. Like 0.1 millimeters, something even smaller than that. Of course, the thicker the spring, the more solid it will be, and less it'll be able to jumble around, which I was having a lot of problem with, like the layers skipping with each other there because everything wasn't lined up correctly. Also, one of my corner clips broke. I'm gonna have to redesign these because I've had this printer for almost a year now. Yeah, that sounds about right. Well, no, I've had it a little over a year, sorry. But yeah, I printed off these clips right about the time when I got the printer, and yeah, they're getting worn out a bit. This one broke, so it's replaced with a binder clip with a bit of rubber backing on it. There's like got rubber around the corners because everything's like out of tolerance, and these things are literally pushing back, so the bed was jumbling around and moving too much. So I'm gonna have to make some sort of adjustable side corners, a lot more stable, a lot more thicker. Probably going to do a higher infill at that, and also need to work on making some sort of adjustable spacer for a Z end stop like thing for this here. I probably will just have this temporary solution, which is just a magnet, the piece of wood, and like a washer to kind of space it properly. But ultimately, I want to go ahead and just tap a hole, make an adjustable screw so I can adjust the height on or as I go here. So I don't have to worry about doing some sort of improvised mess that may screw up in the future. So hope y'all liked today's vlog here. If you did, hit that like button, and hey, maybe consider subscribing to the channel here as well. Definitely helps me out a good bit, and check out some other videos here too. And also check out 3dshapeengineering.com for any of your 3D printing needs.